In this video, I'm gonna go over some of the main types of problems that we can answer about normal distributions. We'll see that there's two main categories of problems of normal distributions that are kind of doing opposite things. And within each category, there is some variation on how questions can be asked and what exactly questions are going to ask for. But what we'll see is that the variation within categories is not hard to deal with. Once we understand that it exists and what we have to do to address that, we'll really see that it's basically two types of questions with small differences between those types of questions. So let's dive right into a normal distribution question. So here we're looking at a very typical normal distribution question. We're told that blood pressure here, this blood pressure will always refer to systolic blood pressure in this problem. Systolic blood pressure in adult males is normally distributed with a mean of 120. The units there are millimeters of mercury, but I'll probably leave that out most of the time. They're normally distributed with a mean of 120 and a standard deviation of 10. So this is very typical of a normal distribution question where all we're told is the variable is normally distributed, and then we're told the mean of the variable and the standard deviation of the variable. Because if you remember, this tells us everything about the variable. That is, once we know something's normally distributed, if we know its mean and its standard deviation, we know all there is to know about it. There's nothing more we could possibly want that completely describes the variable. And so that means that we can answer all sorts of questions about it as long as we know how to appropriately do the computations. All right, so 1A, what proportion of adult males have a blood pressure below 132 millimeters of mercury? Again, we can definitely answer this. That is, we know everything there is to know about the variable, so it must be answerable. So how do we go about doing this? Well, the first thing that I always do in any normal distribution question is I draw a picture. It's an easy step to skip, which is fine if you're getting questions consistently right. But I find that drawing the picture both helps me to remember how to answer the question, but it also makes it less likely that I'll make some silly mistake. That is, drawing the picture grounds us and gives us some sense for what the answer should be. And even if it's a rough sense, most mistakes that you make in these sorts of math problems give you wildly incorrect answers. And so it's actually really useful. All right, so let's draw a picture. So the picture I'm going to draw is just a picture of this normal distribution. And I'm just drawing an approximate bell-shaped curve. It doesn't have to be a nice drawing. And the middle number is the mean, which is 120. Now notice I don't even incorporate the standard deviation into my picture. It turns out the standard deviation tells you where the inflection point is. That's where it turns from curving down to curving up. So this inflection point here would be at 130. That doesn't matter though. That's not important for our drawing. All that matters is that I draw on 120. I draw on 132 on the correct side of 120, right? It's to the right of it. And then what I want to do is I want to shade in the area that the question's asking about. Remember, the whole idea of these probability distributions represented as graphs is that the area under the graph in a region tells us the probability or proportion of the values that fall in that region. So in this case, I want to know the proportion with a blood pressure below 132. And so that's this region that I'm shading in blue. All right, so that's my picture. Not too bad. Now I have to do some calculations. So I need to turn this number 132 into a z-score. Remember, a z-score, and I won't write this for each problem, but to calculate a z-score, we always take our measured value minus the mean and divide by the standard deviation. So in this case, our measured value is 132. Our mean is 120. And our standard deviation is 10. And I'm going to type this into RStudio, even though this is probably unnecessary, right? I'm dividing by 10. I could just do this in my head, but I like to point this out. If you're doing this calculation in RStudio, it's important to put the numerator in parentheses. If you don't put the numerator in parentheses, it won't know that it's supposed to subtract before it divides. And then I get 1.2, which of course is right? We end up with 12 divided by 10. I could have done this in my head. But there's no harm if you're at all unsure in typing stuff in, and it's nice to get practice for using RStudio to calculate basic arithmetic. All right, so the z-score is 1.2, and now I'm going to put this onto my graph as well. So the z-score of the mean is 0, and the z-score of this value is 1.2. So I like to write that down as well. All right, now I want to know the area less than 1.2. And to find the area less than 1.2, in terms of the z-score, I use this command pnorm. The pnorm command in RStudio tells you the area under the standard normal distribution, that is the area under the normal distribution of z-scores, to the left of a value. We'll see these p commands throughout this course. We'll have pnorm for a normal distribution, we'll have pt for a t distribution, we'll have p chi-squared for a chi-squared distribution. It always tells us area to the left, and we'll keep that in the back of our head at all times. So it's area to the left, which is what I want. So pnorm of 1.2 will tell me the answer, and so let's type that in. I get 0.8849. And that's my answer. This is the proportion of adult males who have a blood pressure below 132 millimeters of mercury. So again, just quickly, and I'll speed it up as I go through these problems that are similar. What did I do here? I drew a picture, a very rough picture. I shaded the region that the question was asking about. I calculated a z-score. I put that information onto the graph, and then I determined what do I need to type into RStudio to get my answer. It turned out I needed to type the pnorm command because I wanted this area to the left. And pnorm and p whatever always tells us area to the left. All right, question B. What percentage of adult males have a blood pressure above 125 millimeters of mercury? Well, again, I'm going to draw my picture. Very rough. This is 120. This is 125. Let's write those a little better. And I want the area above 125 because I'm asked about a blood pressure above 125. So this is a bit different from problem 1. I don't want the area to the left, I want the area to the right. I'm still going to calculate a z-score. So it's measured value minus mean over standard deviation. And I'm not going to type this into RStudio, but you could if you wanted to. It's 0.5, right? It's 5 over 10. And I can't just type in pnorm of 0.5. This won't give me the answer. Because remember, RStudio, while it can do a lot of calculations, it can't read our mind. And if I just type in pnorm of 0.5, it's going to calculate this area. Because pnorm is always area to the left. It doesn't know that this question wants the area to the right. But it turns out that's not too hard to fix because the total area is 1. And so if the total area is 1 and pnorm of 0.5 tells me this area, the blue area is 1 minus that. So I need 1 minus pnorm of 0.5. That will tell me the area to the right. So I'm going to type that in. And I get 0.3085. This isn't my answer. It's really close to my answer, but the question asked for the percentage. So this is one slight difference in this question. When we're asking questions about proportions and percentages, we can always ask the same question in 2 ways, either as a percentage or as a proportion. Everything we calculate in RStudio is going to be in terms of proportions. And so if the question's asking about percentages, we have to translate back and forth. And so our answer, to go from a proportion to a percentage, we multiply by 100, or in other words, move the decimal place 2 to the right. Our answer is 30.85%. So that's the percent of adult males with a blood pressure above 125 millimeters of mercury. All right, so moving along. In part C, we have a similar but again different question where now we want to know the percentage of adult males with a blood pressure between 2 values, between 105 and 130. And so I'll draw a quick picture. The mean is 120. And I want to know the percentage between 105 and 130. And it doesn't even really matter if this is to scale. I'm doing this just to shade in this region. So this is what I want to know about. And before going any further, this is definitely different from the other two, right? It's the same sort of question. We want to know an area, but in the other two questions, we had areas of tails, right? This first question had an area of the left tail, this had an area of the right tail. But we're going to see that we can use this in answering this question, but we certainly will need z-scores. So let's get our two z-scores. And so let's make sure we label which is which, although it should be relatively clear which z-score is which, because the z-score for 105 is negative and the z-score for 130 is positive. So for 105, our z-score is 105 minus 120 over 10, which is 1.5. And I should point out as I do this, I chose a problem where the standard deviation was 10 for simplicity of numbers. If our standard deviation is something else, we'll often end up with decimals, and you have to be careful with rounding with decimals. They affect your answers. In this problem, it's not so bad because since we're dividing by 10, everything ends up being a terminating decimal, right? It can't go on forever because all that dividing by 10 does is move a decimal place one over. So here we have z-scores. So it's minus 1.5 and 1. All right, so what is the logic of how I'm going to solve this? Well, I'm just going to write down the first part of the answer, how we solve this. I'm going to start with, and let's put our z-scores in this diagram. I should have done this in the previous problem, I didn't. Let's start with p norm of 1. I'm going to shade in the area that this represents using the laser. P norm of 1 represents this whole area, right? It's the entire area to the left of 1, which is not what we want, right? We don't want this part. But it's not so bad when you think about it, really. We want the first part of the area. We want this, but we don't want this. How can we accomplish that? Well, we actually know what this area is. This is p norm of minus 1.5. So we subtract off p norm of minus 1.5. So just one more quick time. We want this area, and to get it, we start with this whole area, and we subtract off the part that we don't want. So let's type that in. And we get 0.7745. And again, the question wanted us to give it a percentage. And so we'll write our area as a percentage. So this, I've gone through, this is only one of the types of problems, but the three main variations on the types of problems where we're given values and asked about proportions or percentages. So we have the proportion versus percentage distinction, which I think as you work through these is the least important distinction. It matters, but it's easy to deal with. But then the real distinction is, are we talking about area to the left? Are we talking about area to the right? Or are we talking about area in between? If what we want is an area to the left, it's a straightforward p norm that tells us the area to the left. If we want area to the right, we have to do 1 minus p norm. And if we want area in between, we have to subtract the two p norms, and we have to do it in the proper order. We start with the larger one and subtract the small. If we did it in the wrong order, we'd get a negative number, which wouldn't make sense. So hopefully we'd realize, hey, we did something wrong. The other thing I'll point out that is a common mistake, it's really important. These numbers have to be the z-scores, right? If you just type in the values, RStudio, again, it can't read your mind. It doesn't realize if you typed in just 130, it thinks you're talking about a standard normal distribution. So it's really important that the numbers we put in are z-scores. All right, let's move to the second type of question where we're going to go backwards. Instead of starting with a value and giving a proportion or percentage, we're going to start with a proportion or percentage and come up with a value. In part 2, on A, we'll say, well, what's the 70th percentile of blood pressures of adult males? And again, I'm going to start with a picture. My picture always starts the same. It's just a poorly drawn normal distribution. And I draw in the mean. The 70th percentile is saying what value are 70% of things below. Or in other words, the 70th percentile says that the area to the left is 0.7. The total area is 1. 70% of the area is to the left of it. And so the 70th percentile is going to be something like this. It's going to be to the right of 120 because only half of the values are below 120. And we want 70% of them to be below. And I'm going to call this thing X. So I want a number, a blood pressure, that 70% of things are below. And incidentally, I'm going to point out, we actually know approximately what X is. X should be really close to 125. Because we already did this problem where we found that a little over 30% was greater than 125. That means that about 70% is below 125. So we'll be able to check our answer somewhat. Well, that is, our answer should be really close to 125. All right, so how are we going to do this? Well, what we're going to do is we're going to start by figuring out a z-score. So we can't immediately get X, but we can figure out what Z is. And to do that, we use the qnorm command in RStudio. So qnorm, it does the opposite of pnorm. Pnorm takes a value, a z-score, and tells us the area to the left. Qnorm takes an area to the left and tells us the corresponding z-score. So I'll type this in. So qnorm of 0.7. I get 0.5244. This means that the z-score with an area to its left of 0.7 is 0.5244. And just to show you, if I type in pnorm of 0.5244, there's rounding error there, but it rounds to 0.7. Qnorm and pnorm are inverse functions. They're doing opposite things. All right, so this is my z-score. So I know that Z is 0.5244. Now I have to figure out what X is. I have to figure out what this X value is. And to do that, I can use my formula for Z again. Right, Z is always X minus mu over sigma. And I'm going to plug in the things that I know. Well, I know what Z is. It's 0.5244. I don't know what X is, but I know what mu is. Not 136. I don't know where I got that from. And I know what the standard deviation is. It's 10. So I have an equation with one unknown, and so I can solve for it. And this requires algebra, and depending on when you last did algebra, this sort of thing may be tricky or intimidating, but this is as bad as algebra gets in this course. That is, there's plenty of tough math in this course, but the algebra doesn't get really beyond solving these sorts of linear equations. So I'm going to multiply both sides by 10. So that gives me that 5.244 equals X minus 120. And then I'm going to add 120 to both sides, and I'll get that X equals 125.24. Let's round to 2 decimal places. So the 70th percentile of blood pressures of adult males is 125.24, which is about what we thought it would be, right? We knew that our answer would be close to 125. In fact, we knew it would be slightly above 125. And so we have this nice confirmation that unless we made some really bizarre mistake that gave us a really close answer, that this is right. All right, one final type of question in the same vein as this type of question. That is where we're given percentages or proportions and coming up with values. Between what two values do the middle 90% of adult male blood pressures lie? So I'm going to draw a picture. And this picture is maybe a little tougher to draw. I mean, the first part is always the same. We want two values, and we want the middle 90%. So these values are going to be equally spaced. Right? The middle 90% has to be centered in the middle. And I'll call this value like, I don't know, let's call this x and call this y. And what I want is the middle 90% to be between these two. Or in other words, I want this blue area to be 0.9. Now, I still need something that I can do qnorm command with. And the key observation here is that if the middle is 0.9, the two tails each have to be 0.05. And if, just quickly observe, if you add these up, right, 0.9 plus 0.05 plus 0.05 is 1, which is right. And they have to be the same area, so that works out. But if you're saying, wait, how do I calculate that? Where'd this number come from? If I do 1 minus 0.9, that says, hey, give me these total areas, right? Take the full 1, subtract the middle. But then since it's split into two equal areas, I need to divide by 2. So this is how I would calculate this. Sometimes you can just kind of stare at it and figure it out. Sometimes you'll actually want to calculate it. So looking at this picture, it seems to me that I want to figure out this y value, the z-score corresponding to the y value, because this y value has an area of 0.05 to its left. And so I can figure out this z-score by using qnorm. I also could have figured out x. That would have worked as well. It was just staring at me that y had an area of 0.05 to its left, and so I decided to do that. So I got a negative z-score, which is good, right? It's a z-score that's certainly less than average, and so that makes sense. So it's minus 1.64. So that's the z-score for y. And so now I can solve for y. And I end up getting that y equals 109.36. So that's my y value. And I could do the same thing with x, figure out the area to its left and so forth. But the z-score corresponding to x is going to just be 1.64. Because we have this symmetry here. And the symmetry doesn't help us quite as obviously identify what x and y are relative to each other. But the middle is 0 when we're talking in terms of z-scores. And if we have two symmetric values on one side of 0 and on the other side, they have to be positive and negatives of each other. So once I found that this was minus 1.64, I can realize that the z-score for x is just 1.64. And so I do the same sort of thing. And I'm not going to write down all the work, but I end up getting that x is... Ooh, I messed this up, didn't I? I'm realizing I made an error. It doesn't really matter, but I made an error in the y value. We don't want that. So let's fix that. Somehow, as much as I was saying that you can multiply and divide by 10 in your head, apparently I cannot multiply and divide by 10 in my head. So always some value in actually typing things in. And so we get x is 136.4. And so our answer, between what two values do the middle 90% of adult male blood pressures lie? 103.6 and 136.4. So two types of questions at doing opposite things, one going from values to percentages or proportions, and the other going from percentages or proportions to values. Two different commands in RStudio, qnorm and pnorm. But the key here with all the distinctions is drawing this picture and figuring out which areas your problem is referring to. As you get more familiar with these and practice them, I think you may be able to get away without drawing the picture, which is totally fine. Right? That's great, actually, if you can get to the point where you know what you're supposed to do without a picture. But if you're ever finding yourself stuck, or you enter an answer and it's wrong and you can't figure out why it's wrong, draw a picture. It really can go a long way. So hopefully that was helpful in getting you started in doing these calculations involving normal distributions.